Hi classmates, this is Cynthia, and I'm going to be going over questions 13, 14, 15, and 16. In question 13, we're asked to use the original data set and create either a cluster or stratified sample that contains a total of 10 values. We went ahead and used the stratified sampling process, and we separated the data into two groups. The two groups were then divided into basically into half, and we grouped 1 through 63 and 64 through 126, and that was so that each value had an equal chance of being selected. We then ran the random integer code on the calculator, and that generated 5 different random values from each group. Those values were 3, 6, 16, 23, 59, and then from the second group, 71, 76, 79, 89, and 126. And together that gave us this organized sample of 10 values, and that was by the stratified ruling. For question 14, we had to discuss amongst our group the proper process and from the original data set, create a convenience sample. So through the convenience sampling method, we selected 10 values from the data set. And how we did that was we chose 5 values from each group. So the original 2 groups that we created for the stratified sampling. And we chose values that were not selected previously in those other samples. So that generated us, again, another 10 values that were not selected. And those numbers are 1, 9, 15, 32, 51, 64, 91, 104, 113, and 117. In question 15, this was to basically put in all of our data, and I will show you that link right here. So it goes in and has the 126 values for the total fat in grams, and then we have our systematic sampling here, and we have our numbers or values that are selected, highlighted, and organized on this side. Then we go into the stratified sample. Again, we have those numbers highlighted and we have them organized here. And then also the convenience sample, same thing, highlighted and organized here. And then this one is just a organization of all 3 sampling methods and their values. So for number 16, we had to run a 1 variable summary statistics that was done on StatCrunch, and here's our output. We have the systematic sample, the stratified sample, and convenience sample, and that gives you the mean, variance, standard deviation, standard error, and so forth. On this part B, we were asked to provide a whisker plot for each sample, and here you can see we have the systematic sample, the stratified sample, and the convenience sample, so all 3 whisker plots there. And that can kind of show you the general idea of where their mean and quadrants lie too. So on part C, we were asked to use the p-value approach and run an ANOVA test to test the claim that at least one of the samples is from a different population mean. We did that also on StatCrunch, and it shows here, let systematic sample be a sample from a population number 1, and that mean is 22.51. Let a stratified sample be a sample from a population number 2, and that mean is 30.09. Let convenience sample be a sample from population number 3, and that mean was 28. So our claim again is at least one of the samples is from a different population mean. Here we state HO and HA. So that goes and shows you that mean from population 1 equal to mean from population 2 equal to mean from population 3. That was our HO. Our HA is the claim, which is again at least one sample is from a different population mean. Here we have our ANOVA StatCrunch output. That gives you a rundown of all the statistics. We have our systematic sample, stratified, and convenience. That shows us, again, the mean, the total number of values, standard deviation, standard error. Here we have our degree of freedom and our F-stat and p-value. So during this testing that we did, we used alpha 0.5 and a c-value of 0.95. And for that testing statistic, our F-stat came out to 0.57751086. And that, again, is approximately. Our p-value is approximately 0.5681, again, using alpha 0.05. And here we can see that the p-value is greater than alpha, so we concluded with fail to reject HO since the p-value equals, or approximately equals, 0.5681 is greater than 0.05 alpha. There is not sufficient evidence to warrant rejection of the claim that at least one sample is from a different population mean with a c-value equaling to 0.95 and an alpha value equaling to 0.05. Thank you, guys.